Welcome to the online platform Education Unlimited as we continue our search into math. Today's presentation is entitled Trigonometry 3. In our first video on trigonometry, Trigonometry 1, we looked at the definition for trigonometry, features of the triangle, and the various types of triangles. In our second video entitled the Pythagorean Theorem, we looked at the formula for the Pythagorean theorem of right-angled triangles, which is c squared is equal to a squared plus b squared. And then in our third video, Trigonometry 3, we will look at trig ratios of acute angles in right-angled triangles. Look out for our fourth video, Trigonometry 4, where we will look at angles of depression, angles of elevation, and bearings. And then in our fifth video, Trigonometry 5, we will look at the sine rule and the cosine rule. But for this video, I ask that you pay keen attention. I hope that you will like the video. I also hope that you'll share and subscribe to this channel, Education Unlimited, as we continue our search into math. The objective of today's presentation is to get a better understanding and appreciation of the trig ratios in right-angled triangles. The trig ratios in right-angled triangles is the special relationship that exists between all three sides and three angles in the triangle. But now let us define these three sides. So first of all, we have the hypotenuse. The hypotenuse is the longest side in the right angle triangle. And then we have the opposite side. So if the angle A is the angle in question, then the opposite side would be the side opposite to angle A. And then we have the adjacent side. So the adjacent side is the side that is adjoining angle A, but is not the hypotenuse. The basic trig ratios are sine, cosine, and tangent. The formula for sine is equal to the length of the opposite side divided by the length of the hypotenuse. The formula for cosine is the length of the adjacent side divided by the length of the hypotenuse. And the formula for tangent is the length of the opposite side divided by the length of the adjacent side. So in math, we develop three acronyms. So, ca, to. So, sine opposite over hypotenuse, ca, cosine adjacent over hypotenuse, and toa tangent opposite over adjacent. Let us look. The hypotenuse here, the longest side, the angle in question, angle A. So the opposite side is the side opposite angle A, and the adjacent side is the side that is adjoining to angle A, which is not the hypotenuse. Trig ratios. Example 1. If angle A is 30 degrees and side A is 10 centimeters, use the sine ratio to calculate the length of side C, the hypotenuse. So first of all, let us label the triangle. So let us label this angle A, which is 30 degrees, and side A, which is 10 centimeters. So we need to find the length of the hypotenuse. So we apply the formula, which is sine theta is equal to opposite over hypotenuse. So let us put O over H to make it simple. So sine theta would be 0.5. When we plug that into our calculators, it would be 0.5. And the opposite side is 10 centimeters. But we do not know the hypotenuse, so we put h. And then we put 0.5 over 1. So 0.5 divided by 1 is 0.5. And then let us pull a different color. We cross multiply. So that on this side we'll have 0.5 times h. On the other side, 10 times 1 will give us 10. But we want to find h, so we divide both sides by 0.5. Divide this side by 0.5, and we divide this side by 0.5. So that, let's use a different color, this 0.5 cancels this 0.5, so h would be equal to 10 divided by 0.5 would give us 20. So the hypotenuse would be 20. Let us put the unit 20 centimeters. Example 2. If angle C is the right angle, which would be 90 degrees, angle B is 45 degrees, and side A is 8 centimeters, use the tangent ratio to calculate the length of side B. So as usual, the first thing that we will do is to label the triangle. So this side is the right angle, and this is vertex C, 45 degrees is the size of angle B, the degree sign, and we label this side vertex B. This is vertex B, this is vertex C, then we have vertex A. So that side A would be 8 centimeters. So the hypotenuse would be here. We don't need the hypotenuse because we're using the tan ratio. But the side opposite angle B would be side B, and that's the side we want to find. So we pull up the formula. So we say tan theta is equal to opposite over adjacent. Tan theta is 45. So we say tan 45 degrees tan 45 degrees, let's go again, is equal to the opposite side which is side B, over the adjacent side, and the measurement of the adjacent side is 8 centimeters. So, in our next line, tan 45 degrees, when we plug that into our calculators, that value is 1. So we say 1 is equal to common B, side B, over 8. So we put this side over 1. 1 divided by 1 is 1. And then we pull a different color because we cross multiply. So that B times 1 would be B. Just use this arrow here. So B times 1 would be B on one side, and 8 times 1 would be 8. So the answer, B would be, or the length of B would be 8 centimeters. Example 3. If the length of the hypotenuse is 12 centimeters and the adjacent side to angle A is 8 centimeters in a right angle triangle, use the cosine ratio to calculate the size of angle A. So first of all, we label the triangle. This is the right angle, vertex C, vertex B, vertex A. The hypotenuse is 12 centimeters and the side adjacent to angle A is 8 centimeters. And of course, angle A is the unknown theta. The question asks us to use the cosine ratio. So we say cos theta is equal to adjacent over hypotenuse. So that the adjacent side is 8 centimeters and the hypotenuse is 12 centimeters. So that 8 divided by 12 would give us an answer of 0.666, which is approximately 0.67. So let us put the approximate 0.67. So that we want to find the value of this angle. So we want to find cosine inverse 0.67, also called arc cosine. So we plug into our calculator cosine inverse 0.67, give us a value of 47.93 degrees. 47.93 degrees. So that the answer for the size of angle A is 47.93 degrees. So when do we use trig ratios? Number one, we use trig ratios to calculate the size of an angle. Trig ratios are used to calculate the measures of one or both acute angular angles in a right angle triangle if the length of two sides are known. For example, let us label this triangle. That's the right angle. This is the size of angle A. Let us call this vertex A. And then this vertex C. And then this vertex B. The length of this side, the hypotenuse, let us call this example 12. And the length of the adjacent side, let us say it is 10. So as we did in the previous example, we can now use the cosine ratio to find the size of angle A. Note briefly, if one acute angle is known, we could alternatively use the feature sum of triangle is equal to 180 degrees to calculate the size of the third angle. So let us say that the size of this angle is 40 degrees, and we already know that the size of this angle is 90 degrees. So that if we need to find angle B, we say that angle B is equal to 180 degrees minus the sum of 90 degrees plus 40 degrees, and 90 degrees plus 40 degrees is 130 degrees. So angle B is 180 degrees minus 130 degrees. Angle B definitely is 50 degrees. Angle B is 50 degrees. Let's put the degree sign right here. Secondly, we use trig ratios to calculate the length of side or sides in a right angle triangle. Trig ratios are used to calculate the length of one side in a right angle triangle if the length of at least one side and one acute angle is known. Let us remember that an acute angle is an angle that is less than 90 degrees. So let us pull the marker and label this angle 90 degrees and this side 12, that's the hypotenuse, vertex B, vertex C, and vertex A. So if this angle is 30 degrees and we want to find side B, we can use the sine ratio. Just an example, that sine 30 degrees is equal to the opposite over the hypotenuse, and the opposite side is called side B, and the hypotenuse length is 12 centimeters. We could calculate using this formula. Note briefly, if the length of two sides are known, we could then use the Pythagorean theorem to find the length of the third side. So let us pull another color marker. This side is 12 centimeters, and if we calculate this side to be 8 centimeters, we can now use the Pythagorean theorem to find the length of this side, which would have been side A. Thanks for joining us. Look out for our next two videos in trigonometry, trigonometry 4 and 5. Trigonometry 4, which looks at angles of elevation, angles of depression, and bearings, and trigonometry 5, which looks at the sine and cosine rules.